Hello everyone, for this video we're going to talk about word problems involving geometric sequence and series. Now of course, what will be our learning target for this video? I can solve problems involving geometric sequence and series. Just a short recap of the formulas that we encountered when we discussed geometric sequence, finite geometric series, and infinite geometric series. So it is important for you to remember or know the formulas that you are going to utilize in dealing with the various word problems. So take note of this. Okay, so let us start with our first word problem. On the first month, 1,150 ants are living in an ant hill. If the ants double in number every month, how many ants are there on the 10th month? So first of all, if you are dealing with word problems, guys, you need to identify first of what particular concept is being involved or being applied in the problem. But of course, obviously, since the video topic this time is about geometric pattern application on word problems, so of course this is one of the examples of that. And the next thing you should know is, what are you going to solve for in this problem? Are you going to look for the value of a specific term, or are you going to find the sum of a particular sequence being described in the problem? Okay, so of course you will be able to know that if you are going to analyze and interpret correctly the question here in the given problem. How many ants are there on the 10th month? So analyzing this question, then that means we are going to solve for the specific value of the 10th term. Okay, so that means we are supposed to use the formula of geometric sequence, guys. So since we have our formula here already, we can now substitute the data based on the problem given. So a sub n, I turned it into a sub 10 to indicate that we're looking for the 10th term. And we have a sub 1, as mentioned in the problem, we have 1,150, and our ratio is 2. How come that our ratio is 2? It is mentioned here in the problem that if the ants double in number every month, so that means double, so it's the common ratio, it's the indicator of the common ratio, which is 2. And lastly, for our n, since we're looking for the value of the 10th term, so that means our n is 10. Okay, so following the PEMDAS rule, let us consider first the exponent here to simplify. So 10 minus 1, it's 9. And then of course, let's have our 2 raised to 9, that is equivalent to 512. And lastly, let us multiply with 1,150, and therefore our answer is 588,800. So you may write your final answer in statement form. There are 588,800 ants in an ant hill on the 10th month. So you may revise this statement, or you may rephrase this statement as long as we do have the same idea being expressed in the statement. Okay, so moving forward to our next problem. Suppose Jason saves 100 pesos in January, and that each month thereafter he manages to save one half more than of what he saved the previous month. How much is Jason saving after 10 months? Okay, so here again, your first step is, what would be the concept being applied here in the problem? And since again we are dealing with word problems involving geometric sequence or series, so therefore it's an application of geometric pattern. But next to that, you need to look for the common ratio. What do you think is the common ratio in this problem? So as mentioned, Each month thereafter, he manages to save one half more than of what he saved the previous month. So therefore, if we're going to convert the idea of one half into rate, so that is 50%, right? And if we're going to convert that 50% to decimal, so that is your equivalent to 0.5, right? So here, as described, each month thereafter, he manages to save one half more than of what he saved the previous month. So therefore, you add another half of the value of what he saved the previous month. So like for example, in January, it's 100. So what would be Jason's saving on the second month, which is February? So what would be the value as described here in the problem? It's 150, right? So one half more than of the previous month. So half of 100 is 50. So 100 plus 50, it's 150 must be the saving of Jason by February. And how about by March? So you get again half of 150, and that is 75, and then you add it with 150. So that means by March, Jason must save 225 pesos. So that is the pattern. So looking at the pattern, 100, 150, 225. So what would be the common ratio based here in the given problem? So the common ratio is 1.5. Yeah. So you may also check 150 divided by 100 or 225 divided by 150. So that is 1.5. Okay. So next, third thing you should do is you identify what are you going to solve for. Is it specific value only of a particular term, or you are supposed to get the series or the sum of the given sequence? So here, let's look at the question again. How much is Jason's savings after 10 months? So you need to be particular as well of the synonymous words to sum or series, and that is sometimes we make use of total, all in all, and as you can see here in the question, we can also see after 10 months. So therefore, we are going to find out the total or the sum of Jason's savings for 10 months, right? Okay, so that means we are supposed to use the formula for finite geometric series. So here's our formula again. And so let us move on to substitution. So we substitute 10 to n since we're looking for the sum of the first 10 terms of the sequence. Next, our A sub 1 by January, Jason saves 100 pesos. And our ratio, as discovered a while ago, it's 1.5. And again, for our n, it's 10. Okay? So, applying the PEMDAS rule properly, let us manage to have our 1.5 raised to 10. Let's focus first with the numerator, guys. So, I would start with 1.5 raised to 10. And here, I already subtracted the answer of 1.5 raised to 10 by from 1. So 1 minus 1.5 raised to 10. I got negative 56.66503906. So reminder, guys, if you are in the middle of your solution, do not round off yet. So maybe it is advisable for you to round off only at the last part of your computation or solution. Okay, so instead I write it here, the complete answer I've got, which is the decimal number negative 56.66503906, and of course you're using your calculators with you directly multiply it with 100, and that is why I got negative 5,666.503906. Okay, so we're done with the simplifying or evaluating all the operations in our numerator portion, let us now proceed with our denominator. Let's simplify first 1 minus 1.5, and we have negative 0.5. So reminder guys, do not forget the negative sign because it is very important, because this really matters with your final answers. The sign of the integers or the numbers has something to do with your final answers as well. Okay, so moving on, negative 5,666.503906 divided by negative 0.5, I would have 11,333.00781. In this case, or in this kind of problem, so you just take note or be mindful of the instructions given to you by your teacher if you are going to round it off the nearest whole number, or nearest hundredths place, or nearest thousands place. But here I'm gonna use in my final answer, I would have round off it to nearest hundredths place, and that is why I got this final answer. Jason's savings after 10 months is 11,333.01. And we're done with our second problem. Okay, for problem number 3, so same manner guys, so we already identify what particular concept is being involved here. Obviously it's geometric pattern, and as you can see here, the common ratio is not directly described, but we do have the clue right here, since in the problem, if we're going to read this one again, in 2012 the number of enrolled students in a university was 1,045. For the next 2 years, the number of enrolled students is 2,090 and 4,180. If the pattern continues, how many students should enroll in 2017? So even though the common ratio is not described, still we do have the idea, since the 3 consecutive terms of the given sequence is already stated here. We do have the 1045, next is 2090 and 4180. That is why we do have our clue already, and we can use the formula to find the common ratio, and that is succeeding term divided by the preceding term. And so our common ratio is 2. Okay, next to that is you need to identify what are you going to solve. Is it specific value of a term, or you need to find the sum of the given sequence as described in the problem. So here, looking at the question, how many students should enroll in 2017? So analyzing and interpreting the questions, we can say that we are looking for the value of specific term. Okay, now therefore we are supposed to use the formula for geometric sequence, of course. And now let's substitute the given data in our formula. So a sub 6, y6, because we're looking for the number of enrollees by 2017. So maybe you can count from 2012. So our first term here is starting from 2012 data. So 2012, 2013, 2014, 2015, 2016, 2017. So we do have 6 terms or 6 datas involved. Or else you may also use the formula that we had before. We can apply the upper limit minus lower limit plus 1. So we can say 2017 minus 2012 plus 1. It is also 6. Okay, it's your choice of how are you going to find out the value of n based on the problem. Okay, a sub 1 is 1045. Again, our ratio we got a while ago is 2. And then our n again is 6. Okay, so of course, let's focus first with our exponents here. 6 minus 1, we have 5. Okay, and what is 2 raised to 5? It's 32. And lastly, let's multiply with 1045, and we got 33,440. Okay, and of course, let's write our final answer in sentence form. Therefore, 33,440 students should enroll in 2017 based on the pattern stated. Okay, so that's it. Now, let's have our problem number 4. In 2013, the number of students in a small school is 284. It is estimated that the student population will increase by 4% each year. What will be the estimated student population in 2020? Okay, so again, it's an application of geometric pattern. Now, let's find out the common ratio here. So as stated, we do have here the clue that the first term is 284. And based on the pattern, the student population will increase by 4% each year. So it is somehow related to our problem number 2 a while ago, wherein we will have an increase of 1/2 of the previous month. So here, we will have an increase of 4% each year. So given that we started with 284 by the year 2013. So that means if we're going to convert 4% in decimal, that is 0.04. And then it's the increase of the previous month. So therefore, we are going to have 100% data of the last month plus the 4%. Therefore, our common ratio would be 100% if converted to decimal number. So that is equivalent to a whole number 1. But 4% if converted to decimal, that would be 0.04. So if you're going to check it, 4 divided by 100, so that is 0.04. Okay, so add it to the whole number, which is 1. So 1.04 is our ratio. Next is, what are we going to solve right now? Is it specific value again of a particular term, or the sum or the series of a given sequence? What will be the estimated student population in 2020? In 2020 only, and that means you are going to find out the value of specific term only. Okay, so right now, let us identify again what will be our n. How many terms is being talked about or is being described here in the problem. So starting from 2013 up to 2020. So we can also use again the upper limit minus lower limit plus 1, or we can say 2020 minus 2013 plus 1. Okay, so we would have our n is equal to 8. And substituting other necessary data for our a sub 1 and for our ratio we have here. So now, let's start with our exponent 8 minus 1, so it's 7. And what is 1.04 raised to 7? So we have here our answer, 1.315931779. And again, we're not allowed yet to round off in the middle of our computation or solution. So you may multiply it directly with 284. So we would have 373.7246253. Okay. Based here in our problem, guys, since we're looking or we're finding with the student population in 2020, that means we are talking about person or number of students. So that means that our final answer must be a whole number, right? So therefore, our final answer would be, let us just round off 373.7246253 to nearest whole number, and that is 374. And so our final answer would be, the estimated student population in 2020 is 374. For our next problem, we have here the class of 10G supports the coin bank project of the student government. Suppose the class collected 20 pesos on the first day, 40 pesos on the second day, 80 pesos on the third day, and so on. That is, each day, 10G collects twice as much as they did the day before. How much will the class collect on the 6th day? So here, Of course, it's an application of geometric pattern, and we can easily get the common ratio because we do have the values given here. The first term, second term, and third term, we have 20 pesos, 40 pesos, and 80 pesos. So we do have 3 consecutive terms here, and so our common ratio here is 2. 40 divided by 20 or 80 divided by 40, the common ratio is 2. Okay, next target is what are we going to solve for? Based on the given question, how much will the class collect on the 6th day? So we are going to look for the value of the 6th term only. Thus, we are supposed to use the general formula for geometric sequence. And now we have here already. So let us substitute the given data. So a sub 6, since we're looking for the value of the 6th term, a sub 1 is 20, our r is 2, and our n again is 6. So let's have 6 minus 1. Let's have our exponent first. So we have 5. Then what is 2 raised to 5? That's 32. And lastly, multiply with 20. It's 640. Therefore, the class will be able to collect 640 pesos on the 6th day, assuming that the pattern here given is consistent. Okay, so that's it. Here in our next problem, guys, as you can see, it has the same scenario with the problem number 5. But the only difference is that I provided follow-up question. How much will the class have saved all in all after a week? So that means we are going to utilize the same given data. But let us identify this time, what are we going to solve? Is it specific value of a particular term again, or we are going to find the series or sum? Okay, so actually we are going to find the sum, because here we do have the synonymous term or words for sum or series. So how much will the class have saved all in all? So all in all means sum it up, or summation. Okay, so as mentioned here, after a week, so the terms here are being described by day, and so we are going to find the sum in a week. So therefore, how many days in a week? So 7. Therefore, our n will be 7. So substitute all the data already. So s sub 7, and then a sub 1 is 20, our r is 2, and our n is 7 again. Okay, so let us have our 2 raised to 7. Let's focus first with the numerator. So 2 raised to 7 is 128. Next to that, I subtracted 1 by 128, so I would have negative 127. And then still in the numerator, guys, so negative 127 multiplied with 20, I would have negative 2,540. We're done with all the operations in the numerator. Let's proceed with the denominator for the meantime. So 1 minus 2, it's negative 1. Okay, and last operation that we're going to have, we have division. So negative 2,540 divided by negative 1. And so we will have positive 2,540. And so the class will be able to collect a sum of 2,540 after a week. And we're done. That's it. Okay, so for our next problem, problem number 7, suppose Anna saves 50 pesos in January, and that each month thereafter she manages the thrice of what he saved the previous month. How much Anna must save on the 8th month? So you may pause the video for a while, and if you're done, you may resume watching the video to check your answer. So for our answer in this problem, so we are going to look for the specific value of the 8th term, and so we are supposed to use the general formula for geometric sequence. So we have here, and substitute all the data stated or the data necessary. Okay, so I have here Our ratio is 3, and so let's get 3 raised to 7, that is 2,187. Lastly, multiply with the first term, which is 50 pesos, and so I have here 109,350. So our final answer for this problem, Anna must save 109,350 on the 8th month. Of course, let's assume that the pattern being stated in the problem is consistent or is followed. Okay, so last problem. So it is still in relation, or it is related with the previous problem that we've solved, but this time the question is, how much is Anna's savings after half of a year? So here in the problem, the terms are stated or being considered by month. But the question here right now, how much is Anna's savings after half of a year? So how many months is the equivalent of half of a year? And that is 6 months, of course. And what are we going to solve here right now? Is it specific value of the 6th month or 6th term, or the sum of the first 6 months? Okay, so of course, here in this problem, let's gonna find out the sum of the half of a year. Okay, so using the finite geometric series formula, of course. Okay, so substituting the data given in the problem, and of course, let's focus on the numerator first. And so I have here 50 times negative 728, so I would have negative 36,400. And in my denominator, I already simplified 1 minus 3, I got negative 2. And lastly, I will divide both our numerator and denominator, so we'll have 18,200. And that means my final answer would be Anna's savings after half a year is 18,200 pesos. So that's all for this video. Thank you so much for listening. I hope you learn a lot about word problems involving geometric sequence and series. So again, thank you so much for listening, and see you on my next video lesson. Thank you.